Here we go. Okay, we are recording, and I'm a little bit late starting it, but I did remember. So here we are. This is ELC 215, electrical maintenance for automation systems of Durable King. This is February 2nd, 2021, and we are on station 2 on the SMC system, and we're going to be looking at measuring analog signal from if you can take your finger and move that thing up and down there, what Luke is moving up and down, that's an analog signal that's coming from a linear potentiometer that measures the bearing height. When the elevator comes up, it measures the bearing height. And so Eric is going to do a measurement there. We're going to check the output of that linear pipe. We're going to keep it short and sweet here. All we're doing here is this. There's 24 volts at the top there. It goes to a series resistor that drops it from 24 to 10. There's 10 volts applied across that potentiometer, P1. 10 volts, and you get a 0 to 10 analog going into here. Victor, whoever's watching this, that goes into the PLC channel. So 0 to 10. And Eric's going to check from this terminal to common, and we're going to see a 0 to close to 10 variable. J14, which is the wire number 02. Yeah. And then the common, you can go to say X323, be fine. You got to go down below the red to get down in there, below the red and all the way in. So you're all the way in. Now, if you will, one of y'all vary that thing, move it up real slow. Actually, you're at 10 volt now. It's reading 10. So I'm gonna let you see it range. Could go nice or slow for you. We got to see it. Go slow though. Very slow. Very slow. See it moving. So you're seeing a different set of numbers, right? As it moves around. Did you see it go 0 to 10? You see it, McGill? The analog. 2 volts, 4 volts, 8 volts, 9, 10. Now that PLC is reading at a whole lot finer resolution than that meter is. That meter doesn't have all of the resolution that PLC has. It sees it way finer than that. If you see here, Bill, you see it 0, 3, 4, 6, up 9, and then 10. How about y'all see it? That's all I want you to see. It's not a 0 and then slam up to 24 like all the other signals are. It's not that type of a signal. Now for the camera, do it real slow there. 0, and hold on. Let's let you see in the background him moving it. Now go nice and slow. He's moving the plunger in the background. If you see Luke back there, and it goes up 4 volts, 3 volts, 5 volts, 6. 8, 9, 10. But again, this meter, it ain't got all the digits in there that PLC is reading, and it's reading a whole lot finer than that. But everybody get the idea? Mm-hmm. Okay, that's all I want you to see for now. You get a chance to do this because everybody's going to get bugs on this station and on every other station. That's all you need to see at this point. We can click on because we got a lot of stuff to cover. Yeah, I'm trying to get it to where you got all the information you need, and I can start bugging this system, you know. There's a whole lot of things that you need to know that we got to get through. A lot. So now, those of you watching, I'm going to flip to a screen share. And if everybody in here will help me remember that when I go from here to move into the machine, help me remember to move this camera. So whoever's watching, if somebody watches it, they need to see what we're doing. So anyway, I'm going to do a screen share. And we go now. So let's go to your let's go to your study guide and let's find that symbol for that linear potentiometer. So that's page 1. Now, right there. So you can put on there what it is. It is a linear potentiometer. And so the way you spell that, if you go back to your study guide, back to your word bank, right here. Potentiometer, linear for bearing height. So that's how you spell that word. No, potentio that goes before the meter is referring to something that measures voltage, something that has that meters out voltage. So potentio would be like, potential means voltage. So a potentiometer is something that meters out voltage. It gives you, it meters out like a valve, meters water or something, or air. Okay, everybody got it? Okay. This will help you that if you do your symbol study guide as we go, every time we discover a new symbol, we go back in that and go ahead and fill it in before you know it. It won't be long, you'll have the whole study guide filled in, you have something to study for a pop quiz and then a test later. Yes, I do. Yes, sir. Okay, so that's the only new symbol that this in this station here. All the rest of the symbols are stuff that you already know what they are. You know, on the outputs, you know, you have an indicator, a LED, pilot light. You got all these solenoid valves. There's no point in me going over all that again because there's so many repeats on this stuff that I'm not going to repeat a lot of stuff. Okay, I'm just going to point out from here on out what's different with each station. What's different?
On number 6.
Okay, number 6.
We just did that.
That's what we did. Well, number 6 is where we do breakdowns. That we hadn't done any breakdowns yet.
Oh, okay.
I'm saving that. So once you get all the schematics in your hand, I'm going to bug all of them at the same time.
Okay.
And then everybody gets troubleshoot at the same time. And that way we don't have everything's not bottleneck, you know. Mm-hmm. The symbol. Right there. P1. That's the same symbol that's on the schematic. You see on the schematic? if you go back to the schematic, it's right there. It's right there on the schematic. Let me do, everybody got it? What I did a copy paste of that section and put it in your study guide. That P1 thing with the 3 legs on it, the 3 leads, that is the linear potentiometer. You got terminals here that go ahead of it that feed this. All right, so the rest of that station, we don't need to discuss it. But the only other thing that we could discuss about that station would be there's one additional valve that's not on station 1 on the remote IO. So if you go to the next to the last page for station 2, there's an extra valve here that we'll talk about. I'm gonna zoom in. So behind the station where your Ethernet module is, behind the station in your remote IO, behind there, you have an input module with the limit switch that senses the pallet. That's your pallet presence limit switch out here. The rocker switch. And then the other 3 sensors are the sensors that pick up the whole pattern that we don't use. We don't use these 3. You're wired in, but we don't use them. So we don't use these 3. This one we do use. It tells the PLC on the remote input if you got a pallet there. Now over here, we'll talk about one extra valve that's out there on the conveyor belt, one extra cylinder and valve that this station does not have, that station 1 does not have. So I'll zoom in. This is the output module on the remote IO that's behind the machine, just up under there. And so these two solenoid valves here, those 2 solenoid valves are. When you look under here, see where my hand's pointing at? You go straight under there, you'll see 2 solenoids that are sandwiched together on a small little valve like this. You see? If there's 2, only 2 instead of being a lot of them on a valve tank, there's only 2 on that valve tank. Now, one of those valves, it runs a pallet stop. Pallet stop is the one it goes in and lets the pallet sit on the right. That's the one valve that does that, similar to that. The other valve is the one that actually takes this thing here, the little elevator that raises it up. It raises the pallet up, if you notice, when this goes to drop the bearing in. Have y'all noticed that, how it brings it up? So it actually raises the pallet for this here to come down and drop the bearing in there. So it's got like a pallet elevator thing that shoots up and down. You've got a pallet elevator thing, a jack that does that. That's one valve, and the other one is for the stopper. It lets the thing just go on around like that. So they're the two valves. Everybody got it? The one over here, there's no pallet jack or elevator. You only have the stopper that it ducks to let the pallet go on. Everybody see it? So those solenoids that are down there, they're wired into the remote output card that's up under this table here. If you look in from the back side, those of you that are on this side, if you look where I'm pointing with the LED, you see that module set up there? Where I'm pointing now is the Ethernet adapter section with Ethernet jacks in it that goes down to the next station here. And then the other 2 modules in there are the input card and the output card. The input card, it reads this limit switch on, and it reads this switch. And then the output card, it sends the signal to the solenoid that runs the power supply. Or whatever that's in this area here. So that's the remote IO. There's another section here. You notice how they data change? There's Ethernet cable that data changes around. It goes in and it'll data change again. So that's your communication. That cable that one cable brings it even that signal around from station to station. That's how everything is interconnected. You got another one here, another one here. You know, we'll get into, I have a lab, I've got an extra set up a chassis like that, and I'll show you how to set up programming for that remote, how to set the IP address for the Ethernet module, how to put the IP address in there with laptop, and how to test the inputs and outputs with the laptop, how to force the output, make something come on to the computer. So I've got a lab that we'll do in a couple of weeks on that. To set up the addresses for everything in here, the IP addresses. Right, so that's a difference there. But no other differences as far as anything, you know, that needs to be talked about. You know, you got your conveyor motor there and all. So we're ready to go to station. Let's talk about. Did I give y'all one of these for product selection? No. So this is good time to talk about that. We'll do it on the first. I mean, I really think we put one out. You would put it probably in the notebook because it works with station 2, station 4, and station 5. If you don't have one, found it. Okay, so everybody got one? Yeah. Okay, great. So let me pull that up. For whoever's watching, let's see if I can find the folder for that. Give me just a second. Huh? What? Yeah, we'll go with the manual, yeah. Because again, I wouldn't put it with one particular station because it works for 3 different stations. Let me find it here in the computer so I can show it to whoever's watching, recording. Okay, now let's go over the, well, okay, so the reason behind product selection, the subject of that is because this station here, if you look up here, it's got a thick bearing and a thin bearing called a low bearing and a high bearing that can go through it. And at some point, I'll ask y'all to set it up so that what comes out of here would be a low bearing with a nylon shaft, a nylon cover, and that's the only thing I want to get through here. So you have to do a certain button push on the panel so it will pass a low bearing or high and kick out the low. That's what the measurement is. The measurement is all about measuring the one to get good and get on one. Making sure that what doesn't get good, measure this spec of what they're after. So the way to do it, the way the ELC circuit is set up is like this. That for the bearing supply station, if you want to pass a low bearing, you press to start and to stop at the same exact time for no more than 2 seconds. And I'll show you where it says that at. If you go on here, the buttons must be pressed for no more than 2 seconds. If you want to reset a selection, you press the reset button for at least 3 seconds. So if you want to clear your selection, go to the reset button, the blue one, and hold it for count to at least 3. And then it actually goes back to default where it runs all the bearings. It won't reach that end. So, but if you want to select a particular bearing for it to pass, you do the button press for no more than 2 seconds. What I actually do is I press them and count to 1. I'll go 1 and then let go. That's what I do. And then the PLC normally reads it that way, usually. So you would press start and stop at the same exact time. You would go 1 and let go, and it should load that in. It's saying that you want to pass the low bearings, let them run, and then kick out the highs. If you want it to read the high bearing, then you want to press start and reset at the same time for no more than 2 seconds. So you would go start and reset the green and the blue, 1 second, bam, and let go. That's it. And it's supposed to read it. Let the highs pass through and kick out the lows. Okay? And we'll go ahead and do it now. We'll let somebody pick what they want it to pass. Let you load that in there, and we'll run one as we get ready to run station 3, and you'll see they'll kick out what we don't want. What do you want to see it pass? Low or high? Low. We want to see it pass low. So I'm going to put a high down in there first. Actually, there's a high down in there. So you get to see it kick one out. So he's going to come up and do that. So he'll do the start stop. 1 second is not off. Okay. Okay, now, great. So let's put this back up here. Let's go ahead and run this thing. We're going to put it in hold. And let's run 2 or 3 and let you just see. And then we'll move on to all that where we'll start looking at our station 3. You want to change it? Well, it's got to have a wall. Got to have air, so you got to do. You got air in there. Run this thing. If you got air, this is ready. If you place on it right now, so this is ready. So watch it. Watch the ramp here. You see the ramp? Let's get one out. Go ahead. So there goes the high bearing, and it'll bring it up there and measure. So watch. Yeah, watch now. The elevator comes up. It's going to measure. That's your linear pot reading. That analog, and it should kick it out. And it did. See it kick it out? So it's got a low one coming now. It should pass it. This is part of what we call quality control. And I didn't think about the camera in time to do that. I'm not quick enough remembering this stuff to keep the camera everywhere it's supposed to be. I have to hire a cameraman. Anyway, so you saw it did work that one time. Okay, those of you out there, you'll see it when you get there. I'm sorry I missed that. So, but it does what it does what you said it will do, right? So when you flip back to now, when you go back to the sheet up here, the sheet I gave you, the next section on here is for station 4 that has the shafts. So that station over there, it's got nylon and it's got the aluminum shaft. If you want to pass nylon, you do this. If you want to pass aluminum, you do this. So we'll you can actually, since we're talking about product selection, you can go ahead and make a selection over there. We can just let you see that selection being done. So somebody pick, do you want nylon or aluminum to be passed on that machine there on number 4? Nylon. Okay, so do it no more than 1 second. Let go. All right, now, so let's go ahead and let it run on through, and you should see it kick out the aluminum. So I'm gonna see if I can move the camera, maybe. I've got Ethernet hooked up here, man. I've got too much stuff hooked up to be able to move all of this. Right now, I'm tied into the PLC. You could go, well, yes, I'm not going to be able to pick it up from here without unplugging a lot of stuff. Just go ahead and run it. I can't accommodate everything so fast with this.
You got enough here. You got enough to sit up there?
Actually, I can. Go ahead and do it. That'll work. So it's doing nylon. Has it kicked an aluminum out? Well, you got an aluminum coming. You got an aluminum on the way there. So whoever's watching out there, you're going to see an aluminum. See, it's picking up the aluminum there with that sensor. With the gold sensor there, that light coming on, it knows that's aluminum. So the way all this here works is like this. This sensor picks up metal. This one picks up plastic. Now, this didn't light up when the plastic came around, but it lit up when the aluminum came around. And so it's keeping them. It told the PLC what's there, and it's going to, when it shifts, when it gets over here, this here should kick it out. Okay? So we got to have some more parts coming through to do it. You got to have a block. Well, just be prepared to catch that. And we got this here confused right here. Yeah, you're best off not to send something empty here because it's going to confuse it. Now don't pull it out of the suction cup if you like to break something. Wait till it lets go. You out and tear that little thing. You get a small little suction cup. And now you see it kicked it out. So it kicked it out. It kicked the aluminum out. See that? So it knew it was aluminum. And you say, how does it know? It knows it by an inductive proximity. Inductive picks up metal. Ferrous metal. And it just passed it. It picks up plastic and metal. You notice up here that light on is down in there. So it picks up plastic or metal or your finger. Don't put your finger in there. It's not going to pull you on that. It'll have you laying on that power. There's another one ready right here. Right. So we got an issue here that we got to satisfy this thing. Well, yeah, we can clear it. And we got to go back to another rigmarole. Give me a second to think. A fast way to do this could be. No, that's not. It's not going to work like that. Look, pull that back a little bit. Let me try something just slightly different here. Don't do anything different here. I'm going to hit, but don't work against that. I'm going to cut the air off. Look, I'm going to hit the regular stop button that pauses the cycle. I'm gonna fill the air. Now, very gently, lift that arm up a little bit. And now let the pallet go under there. And just let go of it. Now back on out of the way. I'm gonna cut the air back on. And then we're gonna resume like that. So that was a way to do that without damaging something. I killed the air, but I put the pause button on, killed the air, and you could lift it without damaging something, and then we were able to keep on going. We didn't end up having to reset the whole cycle that way. You got to be careful what you do. Don't be rough with it. This stuff is a little bit lightweight. It's not real heavy. You know, there's a lot of technology here, but it's not the heavy duty stuff I've ever seen. It's got that pallet right there. Exactly. See, it knows the darn thing knows. It also the Ethernet stays down there. It knows it. You know, I just got one I think. Well, maybe it didn't get. It's still pulling. If it's still pulling, we got to get a little piece of paper to go under the trip down. But it did his finger, he did that. Yeah. The vacuum sensor that's over here, it was waiting for a closure on the vacuum switch. So it should go get it. There you go, so it kicks it out. So it's working. Your selection, you selected it's working, and it's reading inductive proximity and capacitive proximity. And the PLC is storing that data. Every time the table index, it shifts it to the shift register in the memory and knows what's really spot on that table. So it knows that. Okay. Now, over here, the product selection for this one, there's 6 kind of caps over there. You have a black colored nylon, low and high cover, a white colored nylon, low and high, and you have an aluminum cover, low and high. So the product selection on station 5, if we flip over, let's look close here. Now look on the screen up here for station 5. You got a short and a high aluminum cover on station 5, low and high. There's a low and high black nylon cover and a low and high white nylon. So if you want to get aluminum low cover, you got to put the switch in automatic. You put the select switch in auto low, and you hit start stop for 1 second and let it go, and it's going to pass these. If depending on what you want, the auto manual has to be in a certain position, and then you do these button pushes, and it passes what you ask for. And so somebody in here pick what you want to pass, and load that selection in, and let's see if it rejects everything but that. And let's get the camera set where. Spin it all around. Hey, man. Yes, sir. We got us a team here, man. We got. It needs to be shot this way. If somebody made a selection on it. Right. Okay. Go ahead and pick a selection off your paper. And let's see. That's all you got. Yeah, I actually don't went around that way. Mm-hmm. Yeah. Need to get a little closer. That's still real protected there. Let's move. I actually don't need the Ethernet right this second. I don't need it at the moment, seriously. So that's one thing that can be unhooked just for the moment while I'm moving around.
You got a good battery on your laptop?
I do.
So we can unplug this.
That's right.
See what else I got here. What is this?
Hey, Mr. Earl, I got a longer,
What's this right here?
Well, this is that's the video for up there that we don't particularly have to have, okay? You cut the screen off, hit that gold button 2 times up front. Yep, we don't have to have that either. So for Zoom, they're gonna see it. We ain't got to have the VGA. Just kind of put that over on one of the handles over there. Yes, sir. So we're totally, okay, yeah. Now, this is what I do during the daytime. I Zoom wireless, Wi-Fi.
what kind of cable is that, Mr. Earl? I may have.
It's a USB-A and a C on this end.
I'll see if I have that. I think I have that.
Right, there you go. Great, thank you. Appreciate your help.
Yeah.
So here, you got 6 different kinds of covers on here. So let's talk about those. You've got on each type of material, you've got a low and a high. You know, you've got a short rim and then a high rim. You see how thick that is and how the difference between, well, there's not a big difference between those two. So here, there's a thick one and there's a low one there. On the black high line, there's a high and low. There's a low aluminum and a high aluminum with the rim thicker here than that one. You see that? So there's 6 different kinds of covers here. 6 different kinds of covers. And here's the way it figures out what you have out of 6 different things. This sensor picks up metal. So this is an inductor proximity sensor. The inductor picks up metal. That's capacitive. It picks up plastics and metals. This is a photoelectric sensor that picks up color. So this actually shines a beam down and it bounces, it comes back up. And if it gets the reflection, it knows if it's a light or a dark color. So it's color recognition here for the product. This works like the linear potentiometer. It goes in and measures, but it's a struck reed cylinder with an encoder on it. So they pick something different. It's a digital encoder mounted to a cylinder. So it's a struck reed cylinder with a linear encoder that puts out digital focus to the ELC. This measures the height of the cover. So it measures height like the analog linear potentiometer over there, but this is the digital encoder. It's a different way to measure height, and it's actually built in, integrated with the cylinder. So it's a stroke reading cylinder. It reads the height of whatever it presses against. So it picks up metals, plastics and metals, color recognition, and height recognition here, all 4 of those, and that stuff feeds into the PLC. And whatever you ask for, it takes all of that, figures out what it's got, and as it shifts around and it gets this a lot, it decides whether to kick it out or not. So, which one did you pick?
The first one, what's the first one? Aluminum low cover. I ain't done it yet, 'cause I was waiting.
Right, okay, so for aluminum low cover, it says, what do you have to do to get that?
You gotta hit start, stop, and have it on auto at the same
So
time.
you put it in automatic, it is, and then you'll do that in just 1 second. Now, so it should recognize that. So we got to keep a lot of stuff cycling through here now to see it do that. Okay?
Ready?
Mhm. So it should. Your air's on. So it may be there's a pallet there, it should go ahead and do it. And you hit start, it is that, and the air's on. So and it may be sitting here waiting for something to finish over here. That may be what it is without us going into the PLC.
Go ahead, go ahead and put that plate on.
Put a plate on there.
Hey, grab that one, that way you have the,
Well, you want to put something,
yeah, catch that screw with the ball.
yeah, this is going to be, you got a little bit of, don't get stabbed like that. You just, yeah. Look, I can show you a finger I broke in 5 places. You don't want to try some stuff. I've done some stupid stuff.
That's real thunder right there.
We're best off actually having a block in there. They let it go ahead and do what it's doing. This ain't good here.
I tried to get him to get rid of that one.
It's not safe. It's not safe. Let's don't do that anymore because it's too risky of something going wrong. It was waiting for this to get done. Is what it was waiting on. Little hiccup there. Just gonna check it out here. So now, here's the variation of this is that we're not going to leave it this way under normal circumstances because it's going to work you to death refeeding this thing. It really is. Now there'll be some nights I'll ask you to do it just for the heck of seeing you send up and then it can cut out the product that you want. But when you run it this way, it's going to get worrisome. You know, when it's kicking out so much stuff. What you should see it pass would be, that's a latch, I think that's a high cover. And I think that's a high and that's a low over there. So it'll pass that one and it should reject the high cover. Put them back in with the rims up. Thanks, sir. To see it pass the low aluminum, and it rejects the high aluminum. Now, so if you think about it, this encoder made a distinction between the height of that rim and then the height of the other rim, and it needs. I'm just going to pause it just for a second, and I'm going to put it right back in. You don't ever want to upset what's in there. If you look at the difference between there, there's not a lot of difference in it. There's not a lot of difference in there, but it knows that difference. So, the point is it knows the difference between the heights on there because of the encoder. That encoder that goes back to a special PLC input module. It's actually an encoder reading input module. That's a special thing we'll get into. You'll use an oscilloscope to read the pulses that come off of this pulse. That's for an encoder. This works like a rotary encoder on the back of a motor. It puts out pulses just like a regular encoder does, but it's linear. But it just goes to show you that the system can measure and it can distinguish between heights on things. And so, again, you see how it distinguishes that, and you successfully set it up to distinguish. So, what I would do here is go ahead and put this back on default so it just lets all of them run, and you can hit reset for at least 3 seconds, and it's going to let it run everything. Okay, so you can go ahead and do that. That tells the PLC just let everything run. Ready? Yeah. Now, so we're going to back up now to station 3. We're going to begin our schematic on 3. So that finishes up our topics on 2. So we can click on that to the press on 3. Yeah. I figured it while we're talking about product selection, you go ahead and just see how those 3 stations do it. And so that's an example of how quality control can be a part of a machine. Thanks, sir. Appreciate that. No. Well, actually, the VGA I will. Yeah, the VGA I will, but I don't put the Ethernet. I've got that there just in case of something went wrong, that I can quickly. I can quickly go online with the PLC. Appreciate that. This camera just sure worked out good. I'm not kidding. You know what kind of worry I went through.
Oh, yeah.
With that other camera set up. Yeah, you remember. Oh, man. Yes, sir. Yeah. The problem with this setup is I got so many adapters because the computer doesn't have all the ports I need. But it's okay. Thanks to Walmart.com. Man, I picked up these two adapters over here from Walmart.com. Man, it's got Ethernet, USB-A's, VGA. Man, every bit of that comes out of USB-C. You can get them, man, they don't cost much at all. You know, so I'm just glad to have a hot rod laptop. It runs like a hot rod. It does. It's got an unreal amount of memory on it. Man, I got a ton of these Zoom videos are in there, and it ain't even nowhere near full. Not even close to being full.
So the rest of this stuff on station 2, we're not going to get into the station, right? The rest of the stuff on station 2, we're not going to do it until we get doing it.
Let me look at what that is. I'm having a hard time hearing. Okay, so that's where we were there. So you would explain lamp status. Or what happened? Did my lamp die? Well, something kind of flaked out, and it might be my VGA here. It doesn't say replace the lamp. It just says lamp status not on. Yeah, it's not giving me an option. Sounds like the fan picked up. What's that like? I heard the fan get loud. Let's give it a few minutes for that fan to run in there. The fan kicked in. But look on that lab. Okay, it's coming back on. Yeah, it's coming back on here, I think. Yeah, I saw the green light when you were up here, whatever you did. What did you just do?
I ain't got it like refresh or something like that.
Right. What did you hold it in for a while? Is that what you did? Because I saw that come back on, whatever you did there.
Yeah, it came back coming off the wall, you were touching. So when you hit that, it went off again.
So now the fan's off.
Yeah, just let it cool down for a little bit. It'll come out ready, and then you can hit power.
Right. While it cools down, look, just get your paper out. Let me just tell you what we do next section. So where's my paper at? Yeah, that's the product selection there. All you got to do is explain. You're going to explain in that section. You're going to explain in that section how that linear $10 is applied. Yeah. But I've got trouble if I've got like the key and the regular papers. Now, all you got to do for the next station, while the screen is cooling down, you're going into 67. Look at 67 here. And you're going to briefly explain how this linear potentiometer, how it is hooked up. And all you got to say is that it requires 10 volt DC, and you're using a 1500 ohm resistor to reduce 24 volt down to 10 volt for that sensor. And then the sensor then gives a 0 to 10 volt DC to the PLC. That's kind of a general way to put it. You can say that the linear potentiometer, it's got 3 wires to it. You connect 10 volts across the outside terminals. The 10 volts comes from, you have 24 volts. We reduce it down to 10 volt through a 1500 ohm resistor. And the potentiometer then provides 0 to 10 volt to the PLC. You can, however you want to put it in your words. What we went over up there, you can kind of break it down in short. You know, you can shorten that up.
You can check this out now.
It sure is. Great. Yeah, evidently it must have overheated. It should be coming back on. Mm-hmm. That's an expensive bulb in that thing, man. That thing's a couple $100 for that bulb. I ain't kidding. And boy, it took some looking to find something too, find one. But it's got so much more brightness than the other projector I had. It's just, it does very good even with that bright light in front of it. It's just a strong projector. Now, so right in here, all you want to do is describe what we did. Describe our discussion that we had over here on the board. You're going to describe this. You know, you take 24 volt, we reduce it to 10 volt using a 1500 ohm resistor. The 10 volts is applied across that linear potentiometer, and then it sends a 0 to 10 volt DC into the PLC. That's kind of how you can say it. That's one way to say it. And so I think that's the last thing that'll be said there. If you actually want to draw that, you can just simply draw what I got up there. You can just draw it and yet not even say a word. You can just draw that. Whatever you want to do. If you want to draw it or explain it. Look how you like that. Or you can draw it and explain it if you want to do extra trunks. No. Whatever's easier, you know. Section 8, we're not going to do. They talk about replacing the linear potentiometer with an encoder. The encoder likes on station 5, and we're not going to get into that. It could be done, but there's not time for that. We ain't got time for that. That's a design thing. Ain't got time for that. Ain't got time for that. I ain't got time for that. Yeah. Section 7. That's where you're explaining. That's where you explain, you know. You see, that's where you explain how the linear potentiometer is connected is in section 7. Here I am jumping around like a crazy man. Man, I'm way off. Good gosh almighty. Hold on. Yeah. 103. Station 2. Yeah. This is a real big file. You can't move too fast or you'll be way off somewhere else. Yeah. Right in there, Luke, it's where you put that at about the height measuring sensor. You can either draw that over there or describe it, whichever you prefer. And that, I think that's going to be the last thing you're going to need to do on this particular lab, as far as your paper. Section 7. Is where you would explain how this is hooked up. And after that, you're not going to do the modification stuff. There is one more question that you can answer. And this question at the very, very end of it. And it asks the question, what's the purpose of a circuit breaker? And so that one last question there, what is a circuit breaker responsible for? What a circuit breaker period. What does it do?
Lose power.
It does what?
Breaks the power. Yeah.
It breaks the power if what happens?
Huh?
It breaks it when?
When you set the breaker off.
Well, a breaker kind of works by itself sometimes, don't it?
Yeah. If there's like a overload.
If you have too much current going through it, right?
Yeah.
So that can be the answer there. So a circuit breaker, it's there to protect the circuit from drawing too many amps. If you exceed the rating of the breaker, it's going to trip. Yeah. That's the only other question you would need to answer on the lab. And then you can turn the paper in. So we're not going to try to do anything else tonight. You can finish this up. We will start on station 3 Thursday because it's sitting here. It's almost time to go. If the class ends at 7:55, you got about another, not even 10 minutes. So Yeah, there's no point in starting station 3. You can finish that paper up, you put it in the Dropbox here. Yeah. Try to keep up with your turning your papers in. If you have papers from station 1, if you haven't turned in, I got to go back and check, see who this. I haven't graded anything from 1. Let me go back. This is a good time for me to check that. If you hold on, let me make sure that I've got your paper from 1. And you can go ahead and turn in 2 if you're done with it. We'll finish up on 3 Thursday night, and I think we should be able to do 3 and probably 4 at the same time. That night. And we're going to try to pick up our pace a little bit so we can get, well, actually, we're not going to speed up because you can't learn if you go too fast. We're going to keep moving at a reasonable pace, I'll say that. Once you receive all the information and you got everything in your hands, then I can start focusing too. Plus, we got to have a lab session on using the laptops, how to use the laptops to actually go and view program. We'll do that before I start bugging. Got to have a laptop that's able to get into the program before I start bugging. Okay, so for those of you that are watching, I know it was kind of bits and pieces of things, and it's hard for me to remember that. I've got students helping me now to remember to move the camera around, so we're trying to help you to get at least part of what we're doing. And so we'll do the best we can with this. And you just ask me questions, and if you can get back, when you can get back, you can catch up. So we're trying to get all of the schematics in everybody's hands now, and to look at the differences between each station, what's unique about each station, and where is that on schematics. And we'll pick up on station 3 and 4 Thursday night, and then next Tuesday we should be able to wrap it up with 5 and 6. And then Thursday next week, we should be using laptops to go online to do the logic, to know how to get in there and see the ladder logic. And then from that point, we should be able to start putting some bugs in. And then you will get right onto your troubleshooting labs, which is really going to be 95% of the class will be actually troubleshooting using the voltmeter and using the laptop. I'll be giving out work orders with bugs in the system. Okay, so I'm going to end the session and thank y'all for watching and have a blessed evening. And I hope to see you Thursday. And good night.